Okay, I decided to start my video over, so I already have some things up here, and let me explain what I have done so far. So far we have the problem y equals either the linear equation negative x if x is less than 2, or x minus 6 if x is greater than 2. And earlier today in one of my classes I had written the first equation. Okay, I'll separate these. So the x is less than 2 goes with the negative x. The x is greater than 2 goes with the x minus 6. So each row is its own entity. So I'm going to take my first row, negative x, and put it in as a linear equation just so you can see the y. I am doing what I am doing. And from this, I can tell that m, my slope, is negative 1, and 0 is my y-intercept. And I could, since I know 0 is my y-intercept, I could mark that right here. I'm doing this in pencil because in the future I'm going to do some erasing. So slope is rise over run. I still have a few of you that are struggling with slope. And since it's negative 1, I could either do negative 1 over 1 or 1 over negative 1. They both, when I divide them, equal negative 1 or negative slope. So if I use the first one in red, if negative, I made the numerator negative, then I would be down 1 to the right 1. So from this origin, or where it's 0, 0, the point, I could go down 1 to the right 1, down 1 to the right 1, and I can keep going. And then if I wanted to go backwards or towards the left, I could go up 1 to the left 1, just like it has here in blue. And that gives me my line. And then I can look and say, okay, x is less than 2, and it's an open circle. This one would be the open circle, this one would be the closed circle, because this one is just less than, this one's greater than or equal. This equal sign makes this a closed circle. And circle doesn't look too good, sorry. And then it has glare. So I know I'm going to need an open circle where x equals 2. And I showed you on the graphs today that if x equals 2, where does it hit the line? Well, it hits the line right here at negative 2. And that's where my circle goes. There's another way to do this if you want to check your work. Since I know it goes through all the points going across, or in the diagonal it hits negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, and so forth, hits all these points. How about I plug in 2 just to see if negative 2 is my answer? So I'm going to go ahead and I will do this one in a different color, purple. So I have y equals negative x, and I'm going to plug in, let's say x equals 2. So y equals negative 2. And yes, that's where it hits. And because it's less than negative 2, I'm going to erase everything to the right here because that is more than negative 2. Like here's a positive 2. Here's positive 3, positive 4, positive 5. None of those fit this requirement up here of x being less than 2. So this would be my first line with my open circle. There we go. So there's my first line. My second line is x minus 6. And I'm going to do that again in pencil. Let's go down 1, 2, 3, 4, 5, 6 for my y-intercept. Didn't make my line go down far enough. Okay. And it has a positive slope. So I go up 1 to the right 1, up 1 to the right 1, up 1 to the right, all the way up. And I'm just going up just to show that it is a linear equation. And I can do the same thing that I did down here for my first point, and I can plug in 2 to see where, I think it's going to be -4 because this is where the point is, where 2 is. And it says up here that it does equal 2, but I'm going to plug it in just to show you so you can check your work. So I have x minus 6, so that would be, if I plug in 2 minus 6, which equals -4. So I would have 2, -4 as the point. Whereas over here I had 2, -2 as my point. And this one was an open circle, and this one over here is a closed circle. You probably can't see that, I'm so sorry. There we go. So at 2, -4, right here, I would have my closed circle. And since it's greater than or equal, my arrow would go this way. And I can erase the rest of these points, and I no longer need my y-intercept. And that is the graph. And I already talked today about the domain. It's all real numbers. This graph covers everything on the x-axis, so it would be all real numbers, or -infinity to infinity. In the range, there's nothing below the graph here. It starts, I could even make a dotted line here, just to show you, this is where it starts. So it's, the range would start at -4, because here's where -4 is, and going from negative to positive, it never stops. It goes up towards infinity. So that is the function notation. It's also the same as, well, y is greater or equal to -4. I can't seem to write that, but while I fix this, the Big Ideas book gives us greater to, or greater than, or equal to -4. But in math world, we use function notation, and that would be -4 infinity. So seeing both hopefully will help you understand the function notation a bit more. And it is good to know that there's more than one way to show an answer. I will accept either for the quiz, at least the first quiz, and we'll go from there. So how about I move on to problem number 16. The rest of these I'm going to go through more quickly due to time, because these videos can become rather large. So here we have number 16. I don't want it to be a 15-20 minute video. I'm going to quickly make my line. Now this graph is going to look a little bit different than the Big Ideas graph, because Big Ideas, they went by 4s. They went 4, 8, 12, 16 in this way. I'm going to go by 1s because we don't need to go by these big numbers. Honestly, don't understand why they did, unless they wanted to show you that, hey, there's more than one way to make a graph, and it doesn't always fit nicely on the lines. Well, until you get used to doing the piecewise functions, I think it's easier if you just do each unit as one. So for the first one, I have 2x is if x is less than or equal to -3. So this one's going to have the solid line or solid dot, and this one's going to have the open dot. Okay, I don't want you guys to think that's 30. I probably should have written it down here. So I have 2x if x is less than or equal to -3. I'm going to plug -3 into 2x. So 2 times -3 equals -6. So my point would be 2, -6. That's where the dot would go. So here's over 2, down 1, 2, 3, 4, 5, 6. Something is wrong, because theirs looks a lot different. Did I copy this right? 2x, -3, -6. Yeah. 2. Oh, no wonder, -3. There we go, because that's what I plotted. X is my -3. Okay, now we're back to business. So -3, 1, 2, 3, and down 6. 1, 2, 3, 4, 5, 6. So here's my closed dot. And then all I have to do is look at my slope. It has to be, it's less than or equal to, so I'm going to go this way, and it's actually over 1, oh wait, yeah, down to 1, 2, over 1. So it's going to go off my graph. That's what's throwing me off. Okay, well, now that I did it, I understand why they did it in bigger units, is because it's very hard to see this. It almost goes off the graph if you don't have enough places. Because I only had like 7, and usually, even in homework, you have a 10 by 10 graph. But I wanted to use nice big graph paper. Okay, so for the second one, I can plug in 3 for this. So I have -2 times 3, which equals -6. So I have a +3. And wait, that's -3, so that's a +6. -3, +3. Oh, Mrs. Stallings is having trouble. I plugged in, I need to plug in a +3. And that gives me 3, 6. There we go. And I don't know, it still feels wrong. I might have to do this video over. Let's see if I can figure this out. If it's greater than, oh, I copied the problem down wrong. Okay, that makes me feel better. I had to check and see. It would help if I copied the problem down right. Yep, both are -3. So this is a -3. That gives me my +6. Here's my -3. So -3 and up 6. 1, 2, 3, 4, 5, 6. And my point would go that way. So that's why they did the graph the way they did it. And the domain would be -infinity to -infinity. I'm going to show the original graph. Here they have -3. Here's our -3. Here's our -6. Here's our -3, +6. You can see it goes down and down. Okay, next problem. This one, this is what the answer you'd have in the big ideas. And this is where I started with one of my classes showing if I plugged in a point. So if I have -3x minus 2, and I plugged in -1, I would get 1. So my problem would be, I'd have, my point would be -1, 1. And that's exactly where it hits here on the graph. -1, 1. I can do the same thing with the next one, x plus 2. And let me write above here that this was -3x minus 2, so you know where I got that. And then I have x plus 2, if x is greater than -1. I plug in my -1, so -1 plus 2 equals 1. So again, my point is -1, 1. And if they overlap each other, you go with the solid dot. But we have our piecewise function here that tells us which equation the equal sign goes with, this dot. And again, all real numbers, -infinity to infinity, and it starts going bottom to top at this 1 to infinity. So I have a bracket around the 1, especially because closed circle, if you remember, closed circles are the brackets, and then I have open, well, at infinity with the parenthesis. Okay, so that's through 17. Let me get the last 2 in. Or 3, are there 3? Yeah, 3. So number 18, this one I can just show you too, how they did this by looking at it. So I'm going to take the first equation, x plus 8, and I'm going to plug in 4. So that'd be 4 plus 8, which equals 12. So I had a 4, 12. And that's what they have over here, 4, 12. These go in increments of 4. This one is 4, 8, 12, if I was to fill in all the points. So 4, 12, there's my closed circle, or open circle. Well, we're like, oh, Miss Stallings, that's a closed circle there. Well, that's because if I plug in 4x minus 4 and I plug in 4 for it, I'd have 4 times 4 minus 4, so that's 16 minus 4, which equals 12. So again, my point would be 4, 12, and the closed circle would be right there. So it covers up our open circle. So they both lines share that point, and that's okay as long as when we do the function or the piecewise function that only one of these has the equal sign. They both cannot have the equal. It could either be less than an equal or greater than an equal and less than. Only one of those can have the solid point. And then looking at the graph, the domain, all real numbers is what Big Ideas gives us, which is negative infinity to infinity. And the range, again, is all real numbers. It covers all the numbers on the y-axis. Number 19. They go by twos on this graph. So it's 0, 2, 4, negative 2, negative 4, negative 6, negative 8, negative 10. And in this case, I have 3 equations. Here, if x is less than 3, y equals 1. Remember, that's our horizontal line. So I just need to figure out where the hole is. I mean, I can look at the graph and say, yeah, the hole's right there. Oh, here. At when it's less than 3. So yeah, the hole would be right there at the end of the line. There's nothing to plug in. Sorry about that. So negative 3. The next one, notice there are 2 less than or equal, less than or equals. So we're going to have 2 dots, and notice they have 2 dots here. And we have x minus 1. And looking at that, we could plug in any of these values. Trying to think if my little trick plugging in values will work, and I don't think it's going to be so easy on this one unless I made a T-chart, especially with the way they made this graph. They did do minus 1. This is one where I'm going to have to use the y-intercept, and it's up 1, so it's up 1 over 1, up 1 over 1, up 1 over 1, and that's kind of hard to see on this. So I'm going to show you on a separate graph. What they're doing there, because I think it could be a little confusing. I could show you on that one, but because some of you are still struggling with slope, I worry about staying on the graph that Big Ideas gives you. So we have x minus 1. I can actually plug in both. That's what it'll do. That'll work. So I can plug in negative 3. So I have negative 3 minus 1, and that equals negative 4. So I have negative 3, negative 4 is my first point. And if you look over at the graph, negative 3, negative 4, there's my, negative 3, negative 4, there's my first point. And then I can put x minus 1, and I could plug in positive 3. So 3 minus 1 equals 2. So my next point is 3, 2. And that's where it is here. It's at 3, 2. I'm going to plot that over here just to show you what they did. So I have 1, 2, 3. So I have -3, -4, 1, 2, 3, 4. So there's my first point. My second point is 3, 2, and I'm going to plot that. And then all I have to do is connect the dots, and I don't even have to worry about slope. But I can use, I can use my slope to check my work, because I should have a slope of 1. So it's up 1 over 1, up 1 over 1, up 1 over 1. And look, I have a y-intercept of -1, and that's what is in my equation. So I know this one is graphed perfectly. And let me go ahead and put my 1 up here. If anything less than 3, it equals 1. And that would be an open circle. So here at 3, I put my open circle and my line. And then my last one, -2x plus 4, if x is greater than 3. So I will plug 3 in. -2 times 3 plus 4. So that's -6 plus 4, which equals -2. So I'd have 3, -2 as my point. So over 3, down 2, and I put my open circle. I should have labeled it over here because that tells me open circle. And I can now do my slope, -2. So I could go down 2 over 1, down 2 over 1. And that gives me my graph. So the last thing we need to do on here is figure out, okay, what is the domain and range? And here are the answers. The domain is all real numbers. The graph comes from -infinity. It connects. They both share -3. Keeps going to 3, and then it includes 3, and then it goes to infinity. So -infinity to infinity, or all real numbers. And then here, nothing is greater than 2, so y is less than or equal to 2. Remember, there's a closed circle here. And then it would be coming from bottom to top, -infinity to 2. And 2 is solid, so I put a bracket around it. Okay, last problem, before this video gets too long, if it isn't already. So I have 2x plus 1, -x plus 2, and -3. So 2x plus 1 if x is less than -1. So I'll take 2x plus 1, I'll plug in my -1, so 2, I guess I could put it in parentheses too, but that will bug me because I always like to put the x in parentheses. So 2 times -1 plus 1. So that's -2 plus 1, or -1. So I plugged in -1, so that's my x value, and I got -1. So there's my first point, and it's a closed circle. And then I have a positive slope. So you can check it. If I pick a point here, up 2 over 1, it works. Or I could go backwards, down 2, left 1. That still gives me a +2, because -2 divided by -1 is a +2. My middle one is going to have 2 different equations, or 2 different points in the one equation, I'm sorry. So -x minus 2. And I'm going to plug in -1 for the first one. So I'd have -1, and this one I'm going to plug in 2. That way I don't have to worry about slope, where the y-intercept is. So -1, so negative times a -1 minus 2. That gives me 1 minus 2, which is -1. So again, I have -1. And as you could tell, we'll kind of have a pattern here where it lays off on one when if this one has it, there's going to be another one matching up somewhere along -1. And then if I plug in 2, I'd have -2 minus 2, which is -4. And again, I think I'm messing something up. +2, so a -2, -2 plus 2, I didn't copy that plus sign, right? And that gives me 0. So this would be 2, 0. And they are open circles, and that's what they gave me on the graph. And if you look, 2 is my y-intercept. Boom, there it is. And I have down 1 over 1, down 1 over 1. So the tricky part about these graphs is figuring out which way works for you best. Sometimes plotting the points works, and sometimes just using slope and y-intercept. I could have done all 3 of these without doing any of this work here. But I'm showing you this so you could have another tool to help you graph these. And then this last one, it's greater than or equal to 2. Let me do that a different color. So that is a solid dot. And again, we have a solid dot at x equals 2, y equals -3, and there's my line. All real numbers from left to right, it hits every point. That's what I'm looking to see if the arrows go to -infinity and infinity, and it does. So it's all real numbers, -infinity to infinity. And y is, this one is different. As I told one of the classes today, there's nothing in this spot right here. That's why I have it colored in. It goes from -infinity and it comes all the way up to -1. And I write that interval. So y is less than or equal to -1, or, because we skipped this part, it's between 0 and 3. This part here. Between 0 and 3. And I would write it between 0 and 3. So you can write it both ways. Big ideas will have it this way. I do it this way because that's the way the standardized testing goes. And I want you to do well when you take your SAT someday. And we use this type of notation in Math 3. So that is the first 5 problems. And I'll do another video for the others.